Hi, Spring fans. Welcome to another installment of Spring Tips. I really like security, but I think it's very difficult to do well, and so I try to cover it whenever I can, knowing full well that it's best to stand on the shoulders of giants here, right? Where I'm very happy to riff, to innovate, etc., in lots of other domains. I feel like security is one of those places for which I am just not nearly qualified enough. And so whenever I can, I like to employ tools and frameworks and technologies built by people, purpose-built by people who know what they're doing. One of those tools that I quite like is HashiCorp Vault. Vault is an amazing way to deal with security passwords, right? Credentials, and to store them in a secure way. And obviously it's like a database for credentials, and there's a lot to it. There's a lot to HashiCorp Vault. I mean, at the simplest level, you could just think of it as like another key value store for secure values. And in that respect, I suppose, you could just think of it as another kind of configuration server, another configuration source, just like the Spring Cloud config server or console or whatever. And yeah, Spring will let you treat it like that. You can certainly inject keys and values from Vault and use them as part of the Spring environment abstraction and through the @value annotation and through configuration property objects in Spring Boot. But it also has some other amazing features, and it integrates with a lot of other pieces of key infrastructure in your organization, including your database. It can actually be used, for example, to rotate passwords for your database, right? This is very, very cool because now you've reduced the window of opportunity for hackers who are trying to exploit your system. You can even do things like, if you're paying for the HashiCorp Vault sort of premium offering, you can even say, I want to limit access to change these passwords to business hours, for example, right? Or amazing things like that. You can do hardware encryption, the secure enclave of your computer, the extra secure hardware, right? You can actually have things stored there and integrated with that. I mean, it's just an amazing piece of software. There's a lot of really cool features. And so if you're aware of how to configure, deploy, and administer Vault, you can have everything, your application, your database, your everything secured by Vault, and it has plugins for lots of different things. One of my favorite plugins is the one that works with databases, right? And there's even a whole backend, a storage module in Vault designed to work with and to support rotating passwords for your different databases. And of course, I love Postgres, so I use Postgres just about everywhere I can. It's not surprising at all that it supports Postgres as well. So today, friends, we're going to look at Vault. We're not going to look at Vault as a configuration mechanism. In fact, we've already done that. You might recall way back in 2020, you remember 2020, nothing really happened that year. Famously, we looked at configuration. I looked at the Spring configuration approach, right? The ability to import configuration sources from Vault, from Spring Cloud Config Server, from property files, from the environment, etc. So I'm not going to retread that particular water. I don't feel like it's worth doing. We'll kind of briefly see it in action here, but it's only incidental. Instead, what I wanted to talk about is reloadable configuration and how that integrates with Spring Cloud Vault and the Spring Cloud refresh scope. This demo was driven by the efforts of HashiCorp developer advocate Rosemary Wang. She's really, really, really brilliant, and she's been, I think she even we did something together. She and I worked on an article some years ago, and that article, I think we talked about this as an opportunity, and in that article we used the refresh event, the actuator refresh event, to tell Spring to reload its configuration, and there was some integration there with HashiCorp Vault as an external thing that would then trigger a HTTP request to that endpoint. And so the effect was the same. You have the actuator in turn tells Spring Cloud and Spring Boot to reload its configuration, and everything therein would refresh itself, including the configuration that was being derived from or sourced from HashiCorp Vault, which is good. But it was sort of, it was sort of like the password would get rotated in Vault, and then Vault would have to tell Spring Boot to update itself, as opposed to Spring Boot sort of just knowing to update itself, right? I think it's better if the Spring application can pull the configuration. It can proactively refresh its own configuration as opposed to having to be being told to do so. And so Rosemary, she kept at it. I think she's been working on this, intermittently, or thinking about it. And I think so. Last week she approached me and said, "I think I've gotten a different way to do this." And we worked on it a little bit. And yeah, this is what we're going to talk about today. Is what she came up with. 99% of it was hers. I little tiny, not through the eye of a needle. You could you could fit my contribution. But still, really cool demo. So thank you, Rosemary. Thank you, HashiCorp, for such an amazing piece of technology. So you might be asking, what is HashiCorp Vault? What does it do? Why would I use it? Well, obviously, there is nobody better to answer these questions than Rosemary herself. So I'm going to hand it over to Rosemary. She'll give us a quick debrief on the big picture of Vault, what it is, how it is used, and so on. And then we'll get right into it in a minute.
I'm Rosemary Wong, and I'm a developer advocate at HashiCorp. I work with a tool called HashiCorp Vault, which is a secrets manager that manages the lifecycle of secrets, basically anything that allows you to gain access to another system. These can be certificates, usernames and passwords, or API tokens. Vault is very unique. People like to use it for two main reasons. The first is that it helps you consolidate your secrets in one place and determine who is going to be using those secrets, control how they're being revoked, how they're being created. If you have a lot of secrets in a very large environment, it's very hard to determine how they're being used and which systems are storing them. So if you're storing them in one place like Vault, it's very helpful for auditing who's accessing Vault to get access to the secret itself and therefore using the secret. So it's particularly helpful if you want to verify whether or not secrets are being rotated on a certain cadence or whether or not some old secrets might be compromised. The second reason people like to use Vault is that Vault has certain plugins called secrets engines that automatically revoke and create secrets for you. So if you don't want to manually store the secret in Vault and rotate it yourself, you can ask Vault to handle that cadence for you. It will basically issue a lease for a secret until a certain time period is expired. After that expiration, it will remove those credentials, revoke them from the target systems that it's trying to configure, and anybody who tries to use the old secret isn't going to be able to use it anymore. So it's particularly helpful in improving this overall security of your applications and other services that might be accessing other systems.
All right, let's dive right into it. I'm going to go to start.spring.io. I'm going to build a new app. I'll use Maven. I'll call this a Vault, right? We're going to use Java 21 and later. And then, we can add the Vault configuration support here. And we'll add the web support. You can add the actuator support. And very importantly, we want the Spring Cloud config support, right? We actually want the Spring Cloud core support. It doesn't even need to be Spring Cloud config, so Cloud Bootstrap would be enough. Okay. All right. Let's hit enter and open this up in our IDE. Now, first things first. Remember, let's just connect to Vault here. Okay. So first things first. How do we connect to Vault? Where do we get Vault? What is Vault, etc. And so to that end, I'm going to use a Docker Compose file here. Okay. Copy desktop compose.yaml. Okay. And this Docker Compose file has Postgres, right? It's got a database password, payments, a database called payments, a password called Postgres admin password, and a user called Postgres. And we're exposing it on port 5432. And very importantly here, we have Vault, right? 1.16.1. We're telling it to run Vault server -dev, listen on these addresses. So this is not a production deployment. Talk to your security people. I'm sure they've got a real production environment you should be aware of that uses Vault. And we're going to specify a Vault Dev root token ID. Okay, so we need to remember secret. Okay, ports 8200 and 8200. We're going to run this here. CD Vault. Okay, so that's up and running. Now we'll need to initialize it. So I've got this script here that does most of that work. So let's start with this simple stuff here. We're going to put a simple key and value in there in the database called Vault Demo, and the key will be DB password and the value will be tiger. So let's do that. Okay. All right, so we've added that. Now we want to configure our Spring Boot application to connect to and then work with that configuration. So in theory, we should be able to create a bean here. Okay, read from Vault Demo, right? And let's just make sure we have, this is hello world kind of stuff, but let's make sure that's working. Okay, got a password, PW. All right, good stuff. So there's this. So now I want to, if I want to run this application, I need to authenticate, I need to connect, and I need to integrate. So let's add some dependencies to our build here. We've already got Spring Cloud Starter Vault config. I'm going to add one more here called vault config database. Okay, so copy and paste this, and this will be the extra support for password rotations for databases. Okay, so Spring Cloud Vault config dash databases. We're going to add that to the class path. I have a token and an address as environment variables in my shell. So if I go here, echo vault address, that's pointing to the local vault server, and I have a token, secret. And you can remember we specified this token back here, vault dev root token. This is just for development. This is not how it really works. Normally you'd have to unseal it using 5 different passwords and all that kind of stuff. But okay, for our development, that's there. So this is in the environment. This is in the environment variable space for this Java program. Okay, so when I run it, that's being taken into account. Okay, so we've got this. Now we also need to tell Spring Cloud how to integrate with it. First of all, we want to import the configuration. Here I can say spring config import vault : //. Spring Cloud needs to know about those tokens, right? That token in the URI. So I'll say Spring Cloud Vault URI is vault address, right? And the token is vault token. And of course, I'm talking to a SQL database, but it doesn't know about which one. So let's go check our compose.yaml file. And you can see we've got payments, Postgres admin password, and Postgres. Okay, so let's specify those here. I'll just copy and paste all that for reference. Spring data source post database password equals password. So I'm going to use this. Remember, these are the seed usernames and passwords, right? The very first connection. And then username will be Postgres. And then the database, the URL, of course, is jdbc://PostgreSQL localhost payments. All right. So there we go. So we don't need these anymore. Okay, so now we should have what we need to be able to connect and get, we should be able to connect to our SQL database and to get our one value out of the database and print it out. Let's try that out and see what happens. Okay, our DB password. Okay, so I think we're ready to go. Let's just check our configuration again. Everything looks, oh, hey. Actually, this needs to line up with the database that we used earlier when we wrote that config, right? So do you remember we did vault kv put secret vault demo, right? And then the DB password tiger. So I can change it. I can do vault, which lines up with this, right? If I do that, that'll be okay. Or I can do vault demo, in which case this needs to change, right? For my little simple example here. So I'm going to change this. Well, actually, you know what? Let's just do that. We'll restore the value there, and then I'll restore this to just vault. Okay? So now let's run the program and see what we get. Okay, there we go. Got a password tiger. But now if I go back here to just vault demo, now we've got it in both databases. Let's change the demo name to vault demo because I am a cow, apparently. And we restart this. And that doesn't work, right? So you can see these things are intrinsically tied to each other. So I'm going to just restore it to vault, because why not? That's what the project that we generated is called, and that works out. But just bear in mind, there is a relationship there, okay? Okay, so this is just basic key value, like get a value from the database. But what we want to support is reloadable configuration, okay? And here, we need to enable the database module for Vault, okay? So I'll go back to my command line. And I'll paste the following commands, okay? Let's see what those are. So the first one is enable the database, okay? And there's a path here for the storage, but it could be whatever. And I'm going to enable this right here, this plugin. And then we're going to set up a plugin called Postgres Database Plugin, providing a connection URL, specifying Postgres username, password, the schema, the port, and the database, right? Oh, I'm sorry, this is the host name. And we're going to write to database /config/payments. Payments is the name of our database. It's what the application will do, etc. So the allowed roles are payments app, username is Postgres, and the password is Postgres admin password. The same as we're using. So I'm going to paste the following commands. Okay? And what that's done is it's enabled the database plugin, and I've written using the Postgres database plugin, I'm activating the configuration for that, specifying the connection URL to the Postgres payments database that we're creating here. The allowed roles is the payments app, the username is Postgres, and the password is Postgres admin password. Again, same as we have here, right? Payment, Postgres admin password. And then we're saying we want to write to the roles, right? Not just config, but the roles in the database. We're providing a creation statement. We're saying create role, templated URL there, with login password, templated password, until and then there's an expiration date there, and then grant all privileges on payments to this name, and then specify a time to live. Now, these are nonsensically short, trivial values here just for our demo. And normally you'd have something like once a day or once a week or whatever. You know, the point is you don't want your because even the best password rotation is going to imply some momentary disruption to service, right? So you want to minimize it, but also find a value that is safe. So maybe you do it once a day or once a week or whatever. It's up to you. I'm sure your security people have notes. So now we want to configure the database plugin, which again, remember we have that support on the build, Spring Cloud Vault config databases. So let's go here. And what we're doing is we're saying Spring Cloud Vault database enabled equals true. Okay, good. The role is the payments app. We specified that in the command line just a second ago. And the backend is the database plugin. Okay, so we are on the same page there. We also want to specify the lifecycle for checking on leases and so on. So that's what this is right here. We're, again, super trivial, very brief timeouts just for our demo. Okay, so now we've got all the infrastructure in place. Let's go ahead and write some code. Finally. Okay. So in order to write some code representing some payments, we need to actually have a database called payments. So I'm going to create a schema file here. Just paste all this in. So I'm saying set the time zone as UTC, create the extension if it doesn't exist for PG crypto, create the table called payments, specifying an ID, a name, a billing address, and a created at table column. And then we're going to delete from the payments and then insert a new value into the payments database. Okay. With that, I want to have a controller that returns payment information. And we can just do @bean router function server response, HTTP endpoints. Okay, so payments, good. Server response.ok dot body, and then what are the payments? Well, let's just do a very simple JDBC query. Oh, I don't have the. Did I specify the SQL database support in Spring when I created the project? I don't think I did. Okay, so we need JDBC Command-Shift-I to re-import. And then we'll just inject the JDBC client here. Okay, SQL select all from payments dot query new row mapper, and then we need a payment object, of course. So record payment, and we've got these columns. Here we go: string ID, string name, string billing address, and an instant created at. Okay. So there's that, no problem. Okay. Add this, .list, and then return that. You could actually do a new bean property row mapper, and then just pass in the map to class, payments.class, and voila. Payment. Okay, let's try that, and then that, and then that. Okay, so we've got now our simple HTTP endpoint. Let's make sure that this is working. I have to specify a SQL database driver as well, so go back here, Postgres, copy and paste that, go back to the build, paste it in here, Command-Shift-I, and then reload. And now what? Now it's complaining that I haven't initialized the database. Okay, that makes sense. So SQL init always, and it's not seeing the SQL database. I wonder why. It's complaining that we have ourselves a chicken and egg problem. I need to run this schema here so that the plugin doesn't fail when I try and connect to it on application startup. That's kind of interesting. Okay, no big deal, but now let's restart. Let's just make sure I didn't screw anything up. Do I have everything in the right place? Postgres, oh wait, no, that's not gonna work. Okay, try this again. Here we go. All right, so now it's started. I've made sure to initialize the SQL database. I've got the right schema. It's initialized my table. So now if I go here and click on this, I've got a table here on the left, on the right rather. Go to tables, open this. Okay, so I've got my one record. Now, what if I go to the HTTP endpoint that we just created? Localhost payments, right? What happened now? Well, it's saying there's no argument constructor, so I should have used a different, let's see, is it a record row mapper? Okay, so it's saying that, so I tried it with the bean property row mapper. That didn't work. I have to change it to a data class row mapper. Sorry. The other one's what we would use for a Java Bean compatible thing, but I'm using a record. This is what you use instead. As you can see, this is new in 5.3. It works with data classes in Kotlin, and of course Java records, etc. Okay, written by Jürgen Holler himself. All right, good. So we've got now our simple HTTP endpoint. We're connected. We're not secure, but we are connected. So this is good. I'm going to make a request. Let me go to the browser and make a simple request here. And you can see the problem that when I make the request, I'm locked out, right? It says permission denied for table payments, right? So this is the crux of the issue. How do we update our data source, which is being auto-configured for us here, to reflect this new world? Well, we need to, first of all, take control of how the data source itself gets created. So let's do that this way. I'm going to create a bean of type data source, and therefore these properties, I'm going to still inject them. You can see that they're being injected into the data source properties object, spring.datasource.blah, and then I'm using that to then create the data source properly, using the URL, the username, and the password, and I'm logging out. Don't do this in your code, but I'm logging out for our demo the username, the password, and the URL. This is half of the problem, but it's not all of it, right? We still need to update our bean once once the password has been rotated, and we can do that by specifying @refresh scope. And this will make this bean, it'll recreate this bean whenever a refresh event is published. So we're close, right? This is the hard part. Now, assuming that we have a refresh event, this will trigger the recreation of the bean, which will then be, it's what the JDBC client has is a proxy that wraps the actual underlying thing. So the proxy is still valid. It's just going to forward its invocations to an underlying bean of type data source, which is going to be recreated in situ, sort of whenever there's a refresh event, which gets us to the hard part. How and when do we get the refresh event? And here, friends, we need to write a little. Let's take a look at the genius behind Rosemary's Code, the most important part, which is the listener. So when the application starts up, we have a configuration class. We've got a pointer to the context refresher. This is part of Spring Cloud Context. And we've got an application event, publisher. And when the application starts up, we inject the database role and the backend. That's specified in our properties right here, role, backend, etc. And we are adding a lease listener to our lease container, which is part of the Spring Cloud Vault project. We're going to use a secret lease container, and we're going to add a lease listener. So now we're checking, okay, if the event that's being published is for this particular path, which is our database role, our backend, well, it's our backend and then our database role, backend /creds/database role. If that is the path of the source of the event, then we check and see if it's a secret lease expired event. And if it is, then we publish a refresh event. This is in turn going to activate it'll activate the recreation of all the beans that are annotated with @refresh scope. So this bean will get recreated when that event happens. Okay, so this is the important part. I forgot to specify the KV refresh interval. So I'll go to my properties, add this down here. This is just a custom property that we're using for our own edification. Restart. Okay, so we're up and running. You can see that now our data source is being used to create the username and the password. So now the URL is this. The username is this. Where did we get that from? Well, that's from Vault. Vault is giving us spring.datasource.username and spring.datasource.password, overriding whatever was in the property file here. And of course, this is, random. It looks vToken payments, blah, 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 something, something, something. And so if we go to our endpoint now, refresh, there's the data. But we have to now wait for a little while to see that the value has changed. It's going to get automatically rotated. So I'm just going to let this do its thing. We'll monitor the output here. And while we're waiting, before we start, bear in mind, there's also scheduling on this, right? So this code is actually pretty useful. It automatically refreshes when there's a lease event here, but also if you have a static value like that DB password that we had earlier, and you change that, well, this will refresh whenever it sees that change as well. That's what this interval was for, is to periodically poll every, whatever it was we had in that property file, and then change, publish an event. And we could do the same thing here, actually. We could publish this. We could put this in here as well. We don't need the context refresher. Okay, we'll go ahead and wait. Okay, you can see that behind the scenes we have a refresh event listener, right? And it's recreated the context, basically. Recreated the context with the new credential. And so now, if I want to make a call, you can see the environment properties have been changed, right? So that's fine, but we don't actually have the bean just yet because nobody's using the bean. The creation of the bean is lazy in this respect. So let's go back to our endpoint, make another request, go back to our code, and you can see JDBC, vToken payments, blah, blah, blah. This is new. This is different from what it was back here, right? So it's QS9LEQ, and then go down here. It's e.g. blah blah blah. You see? So the password was rotated, we got updated immediately, and as soon as we tried to then use that data source, it recreated the bean because it realized it was invalid, and so on. So in this way we have refreshable configuration. And by the way, we also have this. There's nothing has changed. DB password has not changed, but you can imagine what would happen if it had. So with this, we now have an application that is using the Spring Cloud refresh event to correctly and usefully recreate data sources whenever the backend has changed. This is a really nice cooperation between the database plugin for HashiCorp Vault, the Spring Cloud Vault project, the Spring Cloud Vault database support as well, and of course Spring Cloud's refresh scope and the refresh event infrastructure in Spring Cloud. All these things come together to allow you to build applications that basically work as before. It's not like my payments controller is any different, right? I did nothing to this. This is just a simple HTTP endpoint. I'm using JDBC, I make the request, etc. But behind the scenes, because I'm using dependency injection and because I have this nice sort of layered approach to building applications, I'm able to seamlessly swap out a data source out from underneath the JDBC client without anything being the wiser. This is a really good result for everybody. It's also more secure. So it's the more secure option while also remaining just as easy. I hope you got something out of this, my friends. A big, huge special thanks to my friend and teacher, Rosemary, over at HashiCorp again for this amazing initiative and effort and work. And thanks to you all, as always, for watching. I hope you got something out of it, and we'll see you next time.